Hello everyone. Today we will talk about our study a mobile app oriented to virtual storage. Why we made this study? Over the years we have seen massive amounts of paper documents piling up in the people's homes and office. And even though it was well organized, it was difficult to find suitable documents and took up a lot of physical space. Some of these documents were needed in more than one place, requiring people to carry them and have multiple copies of the same document.
However, with the advent of the high-tech era, some tedious processes are starting to be digitalized and automated. At the same time, more and more people are starting to abandon the use of physical files and centralize everything in the cloud. This process has brought many benefits to users, as document organization allows multiple access from multiple locations. And with the exponential evolution of mobile devices, it's getting easier.
With the increase of users and enterprises looking for more capacity storage, many companies began to appear dedicated to solving this need by supplying a service. That service is known as within cloud computing as storage as a service, STaaS. It is a business model in which a company sells storage resources, often associated with subscriptions.
One of the advantages is that buying hardware for this purpose implies a high capex, which in the majority of times smaller companies are not able to, make it substantially cheaper to subscribe to the referred service.
One of the biggest providers of this service is Dropbox. This claim is supported by Google Trends, which indicates that Dropbox outperformed its competitors in search. However, Google Drive has more users. Dropbox offers 2 GB in its free version, with additional storage available for purchase depending on your plan. However, in addition to this provider, there are many other providers such as Google Drive and Microsoft OneDrive. Although these providers usually have similar architecture, some providers have more advanced features than others, which can significantly improve the user experience.
In terms of user numbers, it's a clear win for Google Drive. The other two are only 100 million apart from each other. The free storage service is another benefit of Google Drive, as it offers 3 times as much more space than Microsoft OneDrive. Dropbox, on the other hand, offers only 2 GB of free storage, but it can be expanded to 500 megabytes for each invited friend, up to 19 GB. When it comes to selective synchronization, Google Drive is far behind in competition, either Dropbox or Microsoft OneDrive, because the service can connect to physical devices. For Dropbox and OneDrive, you can save your data to both your computer and the cloud. They all have interesting properties, and it should be noted that Dropbox is the most specialized repository and Google Drive offers you the best deals.
Now we will talk about the architecture. One of the biggest paradigms of mobile application is memory, since they have limited memory due to their size. Another paradigm is connecting the internet, because if you are connected to the Wi-Fi, most of the time that access is unlimited. However, when we talk about mobile data, this access is quite limited.
So with that in mind, there are 3 main concepts about this application. First, the online state of the application that supports the communication between the server and the clients. The client drops a file and the file is going to be uploaded to the server, and the user can request a file from the server completely in real time, being that the cell phone there's not a need to store the file. When it comes to offline, the user starts to upload the files. He can store it at most 10 files, because if we allow to store more files, it's going to start to pile up on the application size on the cell phone. So in order to make the request in offline, the user will drop the file in a queue, and you can access those files that are already been downloaded by the application. After the user comes online, the files are synchronized from the queue to the server, and then the process repeats if it's needed when it comes to offline again. The development of the mobile application was in Angular Ionic, allowing to build hybrid applications for both Android and iOS, and to use HTML5, CSS, and JavaScript. At the same time, Ionic communicates with different operating systems. It uses Capacitor, an improved and more recent version of Cordova plugins.
One of the biggest benefits of using Ionic is that you can use the technology that is also used for web development, reducing the need to adapt to new technologies. However, because it is a hybrid mobile development technology, there are some challenges that need to be addressed. Android and iOS operating systems are very different in this respect. And one of the issues that is native access to the device's file system. And each OS requires different code to access different native functionalities.
Results and analysis. When we check the app detail, we have immediately see the benefits of using Ionic. Disadvantage is the size that the application occupies on the device, slightly over 6 megabytes. When the application is online, it uses much less memory when it is offline. One of the main reasons for this is that if the application is online, only the reference to the latest file will be stored in the phone's memory, and not the blobs. However, if the application is offline, it may only occupy the same 15 megabytes as in online mode. But when the file is loaded, the same file is saved on the stack mentioned above. The total file size is reflected in device memory and could scale to a value that cannot be measured if the batch was not limited to 10 files. When the app comes back online, the files are synced with the server and previously deleted from the device to free up memory.
When the logic was assigned to the application side, we saw a very large battery drain. We upload a file within a size of 1070 megabytes for both devices, and both devices all the file manipulation took over 30 minutes. The compressed file has been reduced about 350 megabytes. This application consumed 29% battery on Android device and 25% battery on iOS devices. This heavy battery drain is due to the complex file manipulation logic that is completely handled by the application. That is, use the device hardware for this purpose. However, when all the logic is on the server side, the files can only be processed after they reach the server. So it will minimize the battery drain. Battery consumption is low, but internet usage is directly proportional to the file size. That is a problem as it becomes very limited if the device uses mobile data.
Thanks everyone, that's all.